This day is about designing engineering of the future, and I was specifically asked to talk about design materials in the future. And the first problem starts here. I'm now no expert in materials. I'm a designer. I used to tell my students, and I hope I don't offend anybody here, designers are very superficial, we know, but very broad, and I'll touch on that later. And I think to tackle this topic, I don't want to just focus on materials. I want to look at those four vectors, and I added processes and how they interact and how they influence each other and how they might influence the future, and what it was like in the past. And I'll start with this image because it's a new material. I think it's been around, it's been conceptualized maybe 60 years ago. It was excavated about 15 years ago, and now on any list of future materials, it's a no one. Material, it's the thinnest material known to mankind. I mean, it's one atom thin, it can't be any thinner. It's the strongest material. It's 200 times stronger than steel. If you take a square meter and you make a hammock, you could put a cat there, but it would weigh as little as one of its whiskers, and it would be invisible. It conducts 10 times better than copper. It's harder than diamond. They already make batteries from this material. I mean, Samsung has come out with a battery which charges 5 times faster than a regular lithium ion. So rather than an hour, it's going to take 12 minutes. If you mix it with paint, it will absorb CO2 and it will purify the surrounding air. Like anything else, when there's a new material, they immediately think about new applications. So you have lenses that achieve night vision, and condoms that become ultra thin, and no connection intended here. And we all know it. Okay, I don't know if somebody's heard about it. It's made of graphite. Two guys excavated it in 2004 and received the Nobel Prize in 2010 and for extracting it. And the interesting story is that they extracted it with sellotape. The problem was, how do you get a layer that's one atom thin? And they just took sellotape and just, like you do, you put it together, you take it apart, you put it together, you take it apart, and every time you take it apart, you get less material, and at the end you have one material, and for that they got the Nobel Prize. Seriously. And like I said, we all know it. It's called graphene. And it's exactly the residue that's left on paper when you go, when you make a mark with a pencil. When you make a mark with a pencil, because graphite is built of those one atom layers, you just spread one layer or a bit more on a piece of paper. So that's that material, and people seriously talk about the next graphite age, the 21st century being the graphite age. It has so much potential. But I'm a bit of a skeptic, and I think to see if that's valid, let's look back, okay? Because to a great extent, and I think it was mentioned today already, materials define the development of civilization, okay? So for a few million years, humanity had stone, the Stone Age. We moved to the Bronze and Iron Age, and that just lasted a few thousand years. And here material enabled us tools and new capabilities. But what I find very interesting is kind of to contemplate at the speed of change. Okay, we're so used to change that we see the future actually. We see time moving. But if you lived 2000 BC, you'd have the oil lamp on the left. It's called the open lamp. And it took 1,500 years till the next revolution arrived and the closed lamp appeared. So there was no place for designers, and there was no future, and reality looked the same in one's lifetime and many lifetimes. So it's a very slow development. And I'll jump a few centuries, and I'm moving into, again, a material age. It's the coal and oil age. We call it the Industrial Revolution, but it really, again, it was based on material, and we're kind of getting to the bottom of that barrel. And that lasted a couple of centuries, and energy was the foundation of the Industrial Revolution, and it enabled us to speed up production of goods. Okay, so if we looked at 1,500 years, today we're in an era of accelerated change, and we have a new car model every week. Okay, that's the speed, and these are very complex products. And with that comes the start of design. I mean, prior to that, there were craftsmen, there were people who specialized in materials, and they made it themselves, they excavated it themselves, and they made it in a personal way for their customers. But once you accelerate and you're able to mass produce things, now you need somebody to plan and to support this mass production. Next, what we've experienced over the last 100 years is the plastic age, which we're all familiar with. Definitely designers. I think that's the prime material that we have been working with. And to finalize the 20th century, here the silicon age came along, and it's the foundation of the information age. Silica as a material drives computers. And the question is, what next? Okay, and is it the graphene age that I mentioned in the beginning? Is it the augmented age? Is it the robotic age? The artificial intelligence age, again, was touched upon today. Is it space age? Definitely another lecture. And is it civilization shaped by technology more than it used to be, than materials, what used to be in the past? And what I find interesting when I started thinking about this lecture, and I teach sustainability in Bezalel, is that whenever you have a lecture like this, the future is bright, the new material will solve everything, humanity will just have a fantastic age. And this is just an example from last week. Okay, the space age promises this utopian future, and NASA now opened an Airbnb in their space station, and for $35,000 per night, you can spend some time there, and then oxygen and water, I heard, is included. But again, talking about the future is actually building a narrative, and designers are an integral part of promoting such a narrative. So before we fantasize, let's look at what were the results of our previous narratives. So this is the year I was born. GM creating this utopian view that we all bought into, right? We're gonna be totally free. We're gonna cruise around at high speed, and life is gonna be wonderful. We're gonna move to suburbia, and really great. And reality didn't turn out slightly different. We drive as fast as a horse and cart in LA. People spend 4 hours. Some workers spend 4 to 6 hours commuting. Pollution. And like William McDonough, one of the writers of Cradle to Cradle, likes to mention, we made some major design mistakes. He actually claims that all these mistakes are design mistakes. I mean, we segregated cities. Again, one side of the highway, the poor people, or usually the highways go through the poor neighborhoods. And it's not the small scooters that took over the city. Cars transformed the city. I mean, they became the prime citizens. And I once made a calculation that in Tel Aviv, 40% of the space is given to those big canals or rivers of cars. I mean, and about 2% in Tel Aviv is green space. So many people like to call it the Anthropocene, the human age, because if in previous times geology and natural forces changed Earth, now it's civilization shaping the environment. So before we talk about the next age as a graphene age, I want to look at some of the potential dangers. So let's go back. I mean, we talked about the plastic age. Let's see what happened with the plastic age. What was the promise and what was the result? And this is a very interesting artist, Chris Jordan, and he actually looks at that, and he looks at the disposable culture, because mass production enabled us to produce stuff so easily, so cheaply, that it promotes unsustainable use of materials. And this previous image, here you can see 1 million cups that are consumed every 6 hours on US flights, okay? And he has similar images for cars and phones and fishes, and so it's a very powerful interpretation of how we use material, and we keep forgetting that we are on a spaceship, and the material is very limited. The only thing that comes in is a lot of light, maybe a tiny bit of water, and that's about it. So the materials we have, we use very quickly. Today we need massive material excavation to feed this mass production process. To the extent, and this was phenomenal, that 5 minutes, okay? We're running out of materials. Dubai is importing sand, and this is the end of materials. And you can see this is a map of how much time we have left. Lead, as an example, we have 42 years left, but if we keep consuming it like the Americans do, we have only 8 years left. And do we have a problem? If you ask Trump, there is no problem. It's all a Chinese hoax. There is no global warming. If you ask Victor Papanek, and I'll speed up because I have no time, design is part of the problems. There are few professions that are just as harmful. But at the same time, he says, in an age of mass production, design has become the most powerful tool. And this is kind of an ironic examples of how some designers like to deal with this problem. This is a recent Dutch exhibition. On the left, it's material made with diesel pollution. On the right, it's cups recycled made from recycled toilet paper. Not really a solution. But if I might quote Saifan Borghini, she's a physicist and a futurist, and she teaches at Cholon, designers have a huge task, because we have exhausted the reductionist, the scientific way of thinking, and we need storytellers, we need holistic thinkers. So we need shallow, but people have a very broad approach. And designers should look at behavior change, sharing economy, design thinking, etc. For an example, we're wasting 1.5 billion bottles per day, and SodaStream, and this is a product that we did in the office, is the type of product that allows for behavior change, because you keep using the same bottle, and they're saving now 40 million bottles a day. Obviously, not a huge amount of, but as an example, and I think maybe the biggest new paradigm is the sharing economy and the future of ownership. We don't need to own products. We don't need to throw them away. We can share them. What we actually need is not the products. We need the ability that those products give us. And I'm going back to the Silicon Age because it's transformed. Now I want to move into processes and how it transforms design and manufacturing. So design, obviously, the computer age allowed us to plan very differently. CAD, rapid prototyping, the UX, UI has become part of design. Some people view that we will work like this, and the previous image I showed is our glasses, virtual reality glasses that we made for Lumos. Some very traditional processes like knitting are completely transformed by CNC. If this is a single knit knitted socks that the Viking used, this is a 4D knitted shoe that Nike is developing. Okay, so it's one machine using very different threads and to create a smart textile. Additive processes, okay, again, very traditional, both in clay and jewelry, ceramics and jewelry. But today, with computers, we can actually grow products. 3D printing is a cliche. It's been a huge hype. And I'll do it quickly. But it's definitely a huge promise. It will save time. It consumes less energy. It's local, and it will bring craft back. We have been working on several systems like that. Metal printing, Stratasys, products that you can build or print with all the texture, colors, and real materials. Adidas is exploring and actually brought out the first shoe that's commercial that is being 3D printed for mass production. This year, they're 3D printing a village, again, designed by designer Yves Bihar. It's a whole village that's supposed to be printed this year with all the details. Craft is coming back because now the designer can actually level the supply chain. It can do everything. You can locally print on-demand, personalized products. And AI and deep learning is influencing the way we design. So if on the left you have something that's functional, if you ask a computer to design it in a generative way, trial and effort, you'll get the shapes on the right, very familiar with, very similar to biological structures. This is Sasa Shuach, works in London, also from Bezalel. And these are some chairs that he developed in a similar fashion. And do you have some time just to talk about? No? 1 minute? Okay. So quickly, just to mention glass. I was surprised. We're not looking at glass that much. It's very old. Also connected to silicon. And it's, the silicon, the computer age would not exist without glass. It's transformed architecture, but is running the information age with silicon, with fiber optics that can run, as fast as 17,000 high definition movies per second. It's obviously the basis for UI. This is an example. We made a printing machine from glass, and it integrated all the UI into the glass. And I'll finish with smartphones are based on glass. And now they're developing glass that is, or has to have developed glass that's as strong as, and can fall 100 times on a pavement without braking. And this is the latest. And this is glass by Corning, and it can bend to as small as 5 millimeters, and you can do it for 200,000 times. And that's it. And I won't talk about robotics. I'll just mention that for us designers, I think the next part of the next challenges is how do you develop social products that are autonomous, that interact. And this is a vacuum robot that we designed. And thank you.